All right, today we're going to talk about symmetry. We're starting Unit 2. Yay! All right. We're going to be identifying symmetry. And we're going to describe symmetry in our geometric figures. So a figure is going to have line symmetry. Line symmetry. If there is a transformation of the figure such that the image coincides with the pre-image. And by coincides, we mean like maps onto or like matches up with. So it looks like the same figure again. Matches up with or maps onto. Okay, so another name for line symmetry is reflection symmetry. And that's because it can be reflected across a line so that the image coincides with the pre-image. Okay, so if I reflect this part of the heart in this line, it's going to land over here. And if I reflect this half of the heart in the line, it's going to land over there, and it's going to look exactly the same. That's what we're talking about. You might remember from Algebra 1 when we had parabolas. When we were graphing parabolas, we would talk about an axis of symmetry. That was the line that intersected the parabola at its vertex, and it chopped it in half. It's the same thing. So you should be very familiar with this type of symmetry. Okay, so the line of symmetry, or just like we were talking about, axis of symmetry, divides the figure into two congruent halves. Okay, so here we're going to look for line symmetry in these figures. We're going to say if it has any, and then we're going to draw in the lines. So this one is definitely a yes. It has a lot. Okay, here's one. Okay, here's two. Here's 3, 4. Okay, these are all the ways that I can fold the figure in half and it'll fold onto itself. Now you can see that if I go on to the next point, like I've already done that one. That was my first line, so I don't do that one again. But if I look at the, like in between the points, I have more lines of symmetry. Here's 5, 6, 7, and whoops, that one was crooked. That was brutal. Okay. Here's 8. Now we have 8. Now if you count the points on this star, it's got 8 points, so it shouldn't be that much of a surprise that it has 8 lines of symmetry. 8 lines of symmetry. Okay, look at the next one. All right, I see one here. So this is a yes also. Oops, missing an E. Okay, and then I see another one here. Now, if you look at the star and what we did with the little valleys between the stars, we can do the same thing. So here's 1, here's 2. Now, if I look between the, what are they, protruding parts, I can find my 3rd and 4th line of symmetry. 4 lines. All right, for this triangle, no matter how I fold it, it's not going to map onto itself. If I try to fold it here, this part is going to go, where would that go? Oh my goodness. Like this? Something? I don't know. But it doesn't map onto itself. So this one's a big old no. All right. Next one. This is an octagon. We got 1, 2, 3, 4, 5, 6, 7, 8 sides. It's like a big old stop sign. This one has lots. Yeah. Okay, let's start with the faces and then we'll go to the vertices, the corners. So here's 1, 2, 3, 4. Okay, now you can see that I've done all of the lines to the middle of my sides. Now, if I want more, I have to go to my vertices, which are the corners where my sides intersect. So here's my, that was crooked. Here's my 5th one. And my 6th. Here's 7. And here's the last one. Oops, that was crooked. 8. Okay, so we have 8 again. 8 lines of symmetry. So on our 8-pointed star and our 8-sided figure, we had 8 lines of symmetry. Kind of feels like it might be the start of a pattern. So that brings us to this little bit. Okay, a regular polygon is equiangular, which if you look at it, it just looks like equal angles, and that's what it is. Angles, equal angles. And equilateral. You see the word equal again. And then if you think about moving laterally, like that's side to side, right? Okay. Lateral is sides. Sides. All right. Regular polygons have lines of symmetry equal to the number of sides or angles, because the sides also match the angles. If it's got 3 sides, it's going to have 3 angles. So here we have an equilateral triangle. Okay, all of these sides are congruent. That's what equilateral means. All of these angles are congruent. And you can see that we have 3 lines of symmetry. Okay, for a square, we have 4 lines of symmetry. For a regular pentagon, we've got 5. And for a regular hexagon, we've got 6. Okay, and that pattern keeps going as we increase the number of sides and angles in our regular polygons. Okay, let's talk about rotational symmetry. Okay, we're going to spin. Okay, a figure has rotational symmetry or radial symmetry. You might have heard that word like talking about like a starfish or something, right? Radial symmetry. Hold on, there's a kid outside my door. Okay, you might have heard about radial symmetry when like talking about a starfish or something. It has radial symmetry if it can be rotated by an angle greater than 0 degrees and less than 360 degrees, so that the image coincides with the pre-image. Oh, there's no dash. I feel like I want to put one there, but there's not. So remember we said coincides mean it like matches up? Oops, not matches up. Matches up. Okay, so the angle of rotational symmetry is the smallest angle through which a figure can be rotated to coincide with itself. Okay, look at this example here. Okay, if I rotate this little square 90 degrees about its center, this side will end up here. And you won't be able to tell the difference between the pre-image square, which is the original, and the image square, which is the one that's been rotated, because they'll be identical. It matches up, it coincides, okay? And every 90 degrees, when I rotate it, same thing will happen. It'll line up perfectly. Okay, so this one has 90-degree rotational symmetry, which, coincidentally or not coincidentally, if you divide 360 by the number of sides, okay, you're going to get this angle. Okay, so the number of times the figure coincides with itself as it rotates through 360 degrees is called the order. So this little figure here has an order of 4. Okay, because there's the first one, the second one, the third one, and the fourth one. Okay. Let me go through and show you really quick the positions this side can be in. Okay, so this side is going to start here. That's 1. When we rotate it 90 degrees the first time, it's here 2. And then when we rotate it again 90 degrees, that's 3. And the last time gives us our order of 4. Because after that, we're back where we started to position 1. Cool. Okay. So for these, just like with the line symmetry, we have to say whether it has rotational symmetry, and then we have to say the order. So if I start rotating this triangle, it's not going to line up on itself until I get it back to its original position. So this does not have rotational symmetry. This is a big old no. This little wave figure, it kind of looks like your wave tables in the classroom. So if I rotate this wave figure 180 degrees, it will be indistinguishable from the original picture. Okay, so this one has, yes, it has rotational symmetry. Yes, and it has a angle of rotational symmetry. Oops. I want that to be an A. Rotational symmetry. And the angle is 180 degrees. Okay, if we don't get all the way to 180, we'll have a figure that looks like this. Like at 90 degrees, it'll kind of look like that. That's bad. I'm not an artist, but you can see that if we keep going the full 180, it will line up. Okay. All right, and then we have to say the order. So there's the original starting position, that's 1. And then if we rotate this side all the way 180 degrees to over here, that's 2. Okay, so this has an order of 2. It has 2 positions where it looks identical. Okay, next. Look at this guy. This one definitely has rotational symmetry. So it has an angle of rotation. So let's look at this wedge here. Oops, it's not a triangle. This wedge here. If I rotate this wedge 90 degrees, it's going to line up exactly on that wedge, right? That's a 90-degree angle, okay? So I can tell that the angle of rotation is 90 degrees. The order is 4. Okay, because the wedge can be in this first position, this second position, this third position, this fourth position. and then it's back to where it started so that we don't keep counting. Okay. All right, this one is also a yes. Okay, its angle of rotation is, okay, now this one, if we rotate this only 90 degrees, it's going to be like, oh my God, my brain. It's going to be somewhere over here. It's not going to like have made it all the way around. Okay. So we can get a clue about the angle by counting the number of sides. If I have 3 sides, I can take my 360, divide that by 3, and I get 120. And that is my angle of rotation. So it has to go a whole 120 degrees before it lands on itself again. Okay, so the order is, you can probably guess, but here's our first position, here's our second position, and here would be our third position for this side. Okay, so the order is going to be 3, which incidentally is what we divided by. Okay, now this is the pattern, because if I go back and look at the green one, if I take 360 and divide that by 4, I do get 90. Okay, so these are all related. Okay. All right, we have to describe the symmetry for each icon. So we're looking for line and or rotational symmetry. So if there is line symmetry, we have to draw them. And if there is rotational symmetry, we have to give the angle and the order. So first I'm going to look on this guy for line symmetry. If I draw a line and then I try to map it, is it going to match? Well, no, it doesn't really work. Let me try going this way. Well, no, because the black and white don't match. All right, what about like this? That still doesn't match. So this one does not have line symmetry. So we're going to say no line symmetry. Oops, not symmetry, symmetry. Okay, now let's see what happens if we try to rotate it. If we rotate this white dot 90 degrees, does it look the same? Well, no, because the black dot's going to be over here. It does not look the same. Okay, what if we rotate the white dot 180 degrees? Well, it lands on the black dot, but now we got the black dot where the white dot was. So it kind of almost matches, but not really. So we're going to say that this one doesn't have rotational symmetry either. No rotational symmetry. Okay. That one looks like it should have some, but it doesn't. All right, what about this guy? Let's see if we can find some lines of symmetry. Ooh, there's one. Here's 2. There's 3. There's 4. Okay, so this definitely has line symmetry. Oops, 2 M's. Okay, and it's got 4 lines. All right, let's look for rotational symmetry. So if I rotate this side 90 degrees, here's position 1. If I rotate it 90 degrees, it's going to land over here in position 2. If I rotate it 90 degrees again, it'll land here on this side. If I do it again, it'll land over here. So we do have rotational symmetry. Okay, our angle is 90 degrees, and the order is 4. Is that the end? Nope, not the end. Okay, questions? Okay. Come ask me in class. LOL. All right, look at these ones. Here we have basically the same directions. We have to find the symmetry, so we have to look and see if there's both. Let's look for line symmetry first. Ooh, here's an axis of symmetry. That's one. Okay. Here's another one. That's 2. Here's another one. 3. 4. And here's the 5th one. Not a coincidence that it's a 5-pointed star and it has 5 lines of symmetry. So we have line symmetry with 5 lines. And let's see if we rotate it. So if I rotate this point, I can get it to land here. So this would be position 1, this would be position 2, this would be position 3, this would be position 4, and this would be position 5. So I can tell the order is 5, but what the heck is that angle? Let's start by writing down that it's rotational symmetry. And we know the order is 5. Well, let's take 360, that's a 6, and divide it by the order of 5 and see what angle we get. I already forgot what it was. I wrote it down last night, but I forgot. Okay, 51.4 degrees. So it's not as pretty as the other ones, but it's an angle. Okay, so 51.4 degrees is the angle of rotation. All right, next. Nope, 72. 50, okay, spoiler alert, 51.4 is the next one. This one's 72. Sorry, math is hard. Okay, we'll be fine. All right, so if we look for some lines of symmetry on this one, I see one right here. I see another one here. I see another one there. And another one there. Oops, that was crooked. I can do better. Another one here. And one more. Nope, 2 more. There. And there. Okay, so that was 1, 2, 3, 4, 5, 6, 7. Okay, I'm not going to count like this one because it's already number 4. Okay. Okay, so we do have line symmetry. We have 7 lines. It's weird. Okay, and then we can tell that, let me do this part in orange. Let's say I rotate, let's treat this like a little point, okay? This is the first position for this little point, 1. If I rotate that to here, everything will line up with itself, okay? That's 2. Okay, if I rotate it again, it will land here, that's 3. Here would be 4, 5, 6, 7. So we can tell that the order is 7. It does have rotational symmetry. Okay, now this is the one I looked at before and I got confused. So if I divide 360 degrees by 7, this is when I get the 51.4 degrees. I just looked at the wrong one. Okay, cool. All right, now we are going to, we've got a octagon divided into 8 congruent triangles. We've got to find the image of the given point or segment for the specified rotation or reflection. So we're going to be rotating and reflecting points and segments in this figure. So I'm going to start with point A. Oops. And I'm going to rotate it 90 degrees clockwise about the center. So if I make a 90-degree angle, okay, and rotate it clockwise, I'm going to land on point C. Okay, next I'm going to do H. I'm going to rotate H 180 degrees counterclockwise about the center. Okay, so I'm going to go a full 180 degrees, and I'm going to land on point D. I went counterclockwise. Point D. I lost part of the D. Okay. Okay, we're going to take segment AB and reflect it in the line AE. So here's AB, the segment, and the line AE is this one. Okay, so the thing that we're going to learn about reflections is that however far you are away on one side, then you're going to be that far away on the other side. So this A is actually on the line of reflection, so it's not going to move. Okay, but this little point is going to go here. This little point is going to go here. This little point is going to go here. And you can see that B will end up on H. So we're going to talk about this segment right there. Okay, so that is actually the segment. A stayed where it was, and B went to H. So this will be A, H. Notice the order. The A went to the A, and the B went to the H. Okay, that's going to be really important for us. All right, GH, reflecting in AE. Oh, I should have erased AE. Okay, here's AE again. GH is, where is it? Over here. So, look at this. H is going to go to B, and G is going to go to C. So if the G is first in the GH, I'm going to write the C because that corresponds to the G. So I'm going to write the C and then the B. Okay. Here, let me draw my arrows again. That was maybe helpful. So the G went to the C and the H went to the B. Okay, so now we have to use the figure to answer these questions. We get a new picture. We have to name the image of DR if it's rotated 90 degrees counterclockwise about P. So DR is here, okay? And I'm going to make a little 90-degree thing for D. This is 90 degrees. You can see that D will end up on I, okay? And I'll make another one for R. R, if I rotate it 90 degrees counterclockwise, will end up on G. Okay, so we're looking at this segment right here. So D went to I, and R went to G. Okay. We've got to find BI, the image of BI, if it's rotated 180 degrees clockwise about P. So BI is down here. If I rotate B 180 degrees, it's going to end up on R. Let me write that down, R. Okay, if I rotate I 180 degrees, it'll end up on E. All right, now we have to do AE 270 degrees about point P. All right, so to help us out, let's divide 270 by 90. If you have a calculator, do it. Okay, it's going to be 3. So rotating 270 degrees counterclockwise is just basically doing 90 degrees 3 times. So we're going to go, okay? That's what we're doing. AE. Okay, so if I rotate A 90 degrees, once it goes to R. If I go twice, it goes to G. 3 times, it goes to B. So A goes to B. Okay, now let's rotate E 90 degrees 3 times. Okay, here's the first 90 degree. It goes to D. Here's the second one. It goes to I. Here's the third one. It goes to M. So it's this BM right here. That's the segment. Okay, that's it. That's the notes.